Very good morning. Welcome you all to this NPTEL course on electrical distribution system analysis. And today we are going to talk about a distribution system modeling, a case study to IIT Roorkee system. Now, all of you please try to understand, whenever you carry out any distribution system analysis, your algorithms, logics, that it to be tested on a real distribution system. But engaging your algorithm or hardware integration to a real distribution system become difficult, or sometimes it is not permitted or encouraged by the distribution utility itself. So, we at IIT Roorkee, what we have done, we have developed the distribution system of the IIT Roorkee system, and which has been modeled and simulated further. So, probably all my dear students, if you like to model your distribution network, how a distribution system can be modeled and developed so that you can apply your own logic and algorithms for your validation. Though there are many distribution standards and systems are available under IEEE platforms, but however, bit of practical systems at your local region, wherever you are belongs to, that would be more interesting and more challenging to carry out such simulations. So, let us understand how the IIT Roorkee distribution system has been modeled. Now, first of all, why do we model a distribution system? Software tools enable precise analysis of the distribution system's behavior under various conditions, helping to predict performance and identify potential issues. Testing different configurations and designs in a simulated environment is much more cost effective than real world testing. Now, modeling provides deep insights into the dynamic behavior of the distribution system, including the interaction between different components. Software tools allow for quick prototyping and simulation of new ideas or solutions, accelerating the innovation processes. Simulation can identify potential problems like voltage instability, harmonic distortion, etc., before they occur in any actual systems. Now, optimization of system performance, where modeling facilitates the optimization of system parameters for peak performance, including load balancing, voltage regulation, and loss minimization. Software tools help in understanding and managing the complexities associated with integrating renewable energy sources into the grid. Now, reliability and risk assessment enables assessment of system reliability and risk under different scenarios, aiding in contingency planning and resilience building. Now, today it is important to model a distribution system not only having distribution cables and substations, but also having bit of renewable integrations, storage integrations. So, modeling a whole system of distribution network, including energy storage devices along with your PV integrations, become quite challenging and interesting. Now, educational and training purposes, when you like to teach someone about distribution system, so they are invaluable for educational purposes, providing students and new engineers with hand-on experience in power system operations and design. Regulatory compliance testing can be used to ensure that the system design complies with national and international standards and regulations. Now, facilities the design and testing of smart grid technologies like demand response, grid automation, and advanced metering infrastructure is equally important to carry out such modeling of distribution systems. Now, visualization of system operation provides visual insight into the operation of the distribution system, which can be useful for both technical and non-technical stakeholders. Different software tools offer various degrees of customization, allowing engineers to adapt the models to their specific needs. Data analysis and reporting enables comprehensive data analysis and helps in generating detailed report for technical evaluation, decision making, and planning purposes. Now, this is quite interesting. As you could see, the diagram which is representing IIT Roorkee distribution system, and this is my 33 kV bus, which has two very important substations with 33 upon 11 kV each. Okay, and then probably we can see it goes as down as, and there are many transformers which are 11 kV upon 415 volts, and there are few black boxes that you can see. You could see 1, 2, 3, 4 and 5. So this is one of our future study at IIT Roorkee distribution system, where we are planning to place 5 different battery energy storage devices in the network to accommodate more than 2.5 megawatt of PV, which are already in place. Now PVs also you can see, there are different departments as you could see, and the rooftop we can find bit of PVs that I will show in my next future slides. So currently we do have 2 storage technologies, and probably in future the institute may think of extending this to 3 more points. Now, as an introduction, as you could see in detail, these are actually 35 locations starting from 1, 2, 3 up to 35, and these are the PV installation do exist in those points, and approximately 2.7 megawatt of PV installation do exist in this campus. You can refer this article by Sen Gupta and et al., where you can get more detailed insight into the distribution system of IIT Roorkee. Now, we have also, tried to provide bit of transformer ratings as well as capacitor bank ratings for you people to carry out some kind of simulation. And as you could see that, they are all 3-phase distribution networks, and these are the transformers do present at 11 kV substations, and the capacitor banks and the ratings are available to you for ready reference. And there are 16 substations with transformers and capacitors inbuilt. Now, one of the most important part of distribution system modeling is cable modeling, because nowadays overhead distribution lines are not being appreciated, especially the modern cities. So, for example, IIT Roorkee, we do have actually most of the networks are underground cable. So, cable modeling is an important part of distribution network modeling. So, underground cable modeling involves calculating resistance, reactance, capacitance and impedances to understand voltage drops, power losses and fault conditions. Integrating cable modeling into distribution network analysis improves power flow optimization, enhances system reliability and support strategic planning for future expansions. It helps in identifying potential issues and planning maintenance activities to prevent outages and extend the cable life. Now, these are two segments, where one is for your 11 kV underground cables and 415 volt underground cables. As you could see, the matrix for R, X and C, and similarly for 415 volt you can find R, X and C. So, this is basically a typical structure of the cables currently in operation at IIT Roorkee campus. These are the line segment datas of the for different bus to different bus connections, and these are bit of loads. So, these are the 415 volt buses, okay, and we have different points and the codes are given here, and probably the load points also you could see. But these loads are actually varying, they vary with time. And at IIT Roorkee campus also we have captured the load profile of hostels, departments and residential. So, we divided the campus load into 3 segments. One is hostel section, department section and residential sections, and different time duration during spring, summer and autumn, how those load profiles behaves, they have been captured. And another important thing, for each department level, For example, how with differentiation they are going to behave. So we have plotted spring station, hostel, department, residential, and for each department, hostel and residential, for spring, summer and autumn, how they are going to behave, they have been captured. So the main idea here is to advise you that this may vary for your own campuses or own distribution systems. So we need to create your own profiles by taking smart meter readings to capture those characteristics. So this is IIT Roorkee network standard operating configurations. So what we do, actually CB1, CB2, CB3, 4, 5, 6, 7, 8, they all are closed and open. The feeder section between 3 to 4, 7 to 8, 11, 10 to 11, 14 to 15 are ideally kept open. But with time, depending upon the emergency, the scenario may change. So this is the IIT Roorkee map. As you could see, the geography of the map. And now you could see the amount of PV installation that takes place at different point. As I told you, there are 35 locations and approximately 2.7 megawatt of PV integration at IIT Roorkee campus. Now these are the smart meters connected at IIT Roorkee system. And we can also see, because we do have a new SCADA setup at IIT Roorkee campus. So this is my IIT Roorkee SCADA overview, where you could see the different locations have been modeled: wind tunnel, earthquake engineering, Kasturba Bhavan, high voltage lab, and so and so. And one can see the real-time parameters at each and every location. So this is the 11 kV system, as you could see at SCADA at different locations, and the substation data also can be captured at different points. So this is my 33 upon 11, and there are a bit of 11 upon 415 too. So this is your RSCAD draft interface. Before you simulate, you need to create a draft interface of your network before you carry out real-time simulation in RTDS. And this is your RSCAD runtime interface, because distribution system is quite large. So you have to, after creating draft, you can interface. And once you integrate PV to the network, so then also you can measure how the voltage is going to change over a period of time. So with different buses at spring, summer and autumn, you could see how the voltage profile is keep on changing. So these are points you could see the voltage is significantly high, which is going beyond 1 per unit. That means the nearest substation must be having huge amount of PV integration, and hence the voltage experience at those substations are reasonably high. So Open DSS interface, as you all know, this is a platform, simulation platform that can be used for simulating any model distribution networks in future. And this is the Open DSS in MATLAB framework. This is very important for all of you. So we call it is the distribution system simulator, and where all the details of line, load, capacitor, PV, battery data being injected to my DSS platform. And there is also a MATLAB which is now talking to my Open DSS at different interval. I can carry out load flow. Perhaps I can also carry out optimal power flow. Now this MATLAB do have connection with Gurabi software. So you can welcome Gurabi to MATLAB as well as DSS. And the interface data between Gurabi can be shared to my DSS to further integrate it to MATLAB. So MATLAB can engage both DSS and Gurabi to carry out any optimal power flow or load flow analysis of distribution networks through a modeled network parameters and data which is made available to me. For example, IIT Roorkee distribution system, I can obtain the voltages at each and every load bus subject to the modeling is correct, and the software platform can be used to simulate the data. You can also refer to an article published in IEEE Transaction on Industrial Application by Tripti Gangwar et al. And the voltage variation with and without PV is quite interesting to observe. because as you all know that when there is a PV integration, probably the voltage at that particular location will increase. So we could experience the 12th hour highest PV and 23rd hour the 0 PV, and this is my maximum voltage and minimum voltage setups. So at different buses, you can see how the voltages keep on fluctuating because of PV integration from time to time. So with this, we come to an end. So what I like to highlight that any distribution system modeling is very important for any one of us to carry out distribution system analysis. We can capture the ready-made IEEE standard distribution systems, but if you are interested to decide that what are those locations where my PV can be installed, if it can be installed, what would be its magnitude? For that, you need a simulation study of your own distribution network, and for that, you need modeling. And once you model, we can identify optimal locations and their magnitude of PV integration so that your overall system become efficient. And similarly, if you like to put some storage devices, you need to carry out certain simulations to understand what are the optimal locations of the distribution system, such as IIT Roorkee campus today, so that the magnitude of energy storage devices can be installed in the distribution to efficiently engage your PV charging and discharging capabilities. So with this, we wish that all of you can go back and experiment some ready-made networks for your distribution network simulation. And if you wish, you can go for a new practical setup to carry out your distribution system analysis with renewables, with PV, with wind, as well as energy storage devices. With this note, thank you very much for your kind attention. Thank you.